In this chapter, we are going to talk about the weight and balance of the airplane. To make the weight and balance calculation, we have some documentation such as the weight and balance sheet, also including in the onboard equipment of the airplane. If we look detailedly in our weight and balance sheet, we are able to see the one example of the weight and balance calculation, and according to this example, we can also make the own calculation. There is another way, which is the second one. We also can use our pilot operating handbook or the aircraft flight manual to check the weight and balance graph or the weight and balance table. According to this table and the graph, we can make our calculation, and according to our calculation, we arrange our fuel or the baggage area. And each flight, we have to make the own calculation to be sure that we are in the limitation. If we are nose heavy or the tail heavy airplane, our limitation will be changed, and it's not permitted condition to fly. And each flight we have to be checked. We are in the limitation about the center of gravity and our weight limitation. In order to understand the weight and balance of airplane, we have to get familiar some terms to make the weight and balance calculation. This is our airplane profile. Our airplane is the Diamond DV20 Katana model. And then we have the datum line. Datum line is assigned by the manufacturer. It's the imaginary line to calculate the oar momentum easily. Some aircraft has the datum line in front of the nose. Some aircraft has the datum line as exactly the fireball, but we have the datum line. It's the almost middle of the canopy of this airplane. And thanks to this datum line, we are able to make our weight and balance calculation. It doesn't change when we are making the calculation. It's like a reference point to calculate our momentum. And the second one is the arm. Basically, arm is the distance from the datum line to our weight. For example, we have the baggage area behind our cabin. Also, behind the cabin we have the fuel, and in the cabin we have the pilot seat and the co-pilot seat. When we sitting on the aircraft, we have to look to our distance to datum, and we will make our calculation according to this distance. Basically, momentum equal weight multiply arm. You may think like a momentum equal the weight multiply the distance of the datum to our weight. And I think you have been tried playing when you are the child. You have been tried to play the seesaw, and then you are able to see this momentum easily. How we can change our momentum. If you look, there is some pivot point, and then here is the big guy and here is the smaller one. If we would like to make equal this at the same level this seesaw, we are able to change our pivot point to close the bigger one, or we are able to move the bigger guy to close the pivot point. And then you may think the momentum something like that. If we have to make our calculation, we can change our position of the weight, or we can change the pivot point. But in our airplane, the datum line is the steady, and that's why the reason we can change our weight to close the datum line or the far away the datum line according to our calculation. But end of the day, before going to fly, our center of gravity and the weight should be in the limitation to perform the flight. Also, we have to know another term such as the basic empty weight. Basic empty weight, or front passenger and rear passenger, fuel, and the baggage compartment, and also the oil. We have to know these all things to make our calculation, and then we will see that we are not the nose heavy or the tail heavy, we are in the limitation. The basic empty weight, the all aircraft weights, which is just including the without passenger, without baggage, without anything, just it's including the unusable fuel, and also normally it's including the oil, but if not, we have to check the oil again. But mainly, at the basic empty weight, we consider the aircraft weight, unusable fuel, and then the oil. If after that, we have to check the front passenger seats. For example, if you are the two pilots, and then you will be for example, 150 kilograms, something like that. And for the real passengers or aircraft, as I said, just two-person airplane. That's why the reason we don't have the real passengers. And then we have to check the usable fuel, and we have to check the baggage compartment. And how we do that? The momentum, as I said, the equal weight multiply arm. We just putting the all weights over their basic empty weight, the front passenger, fuel, baggage, maybe oil if it's not including the basic empty weight, and then we are checking the arms, and we find our momentum. And after that, we making the summarize of the weight, and we find our total momentum. If we divide total momentum to our weight, I will find the center of gravity position, and then I can change thanks to the graph our center of gravity and the momentum. Now let's look my example of the weight and balance calculation of the airplane to see our real life application. According to my example, I wrote over there the basic empty weight and pilot and passenger weight. We will write over there the weight, and as according to formula, we multiply the arm, and then we will find the momentum. Let's look at our basic empty weight according to our pH, which is the 520 kilogram. And our arm, which is the 0.285. And if we multiply these values, we will find 148.404 kilogram meter. And then I will continue with the passenger and the pilot seat. Remember, we just have a two seat, and that's why the reason we have just front seats, passengers. And at that point, I said 172 kilogram for this pilot and the passengers. And at that point, I would like to mention Diamond DV20 Katana model of airplane. For the one seat, just can seat of this 1 to 110 kilogram is the maximum capacity of the one seat. If you are fatter than this 110, you are not able to fly with this airplane, or airplane will not able to fly with you. And our arm is the for the pilot and the passenger 0.143 meters, and if we multiply these values, we will find 24.596 kilogram momentum, correction kilogram meter. And then I will continue with the baggage. At the baggage, I prefer to don't put anything, because I would like to put the fuel in my airplane as much as I can. That's why the reason at the baggage area I set 0 kilogram. And then our level, if you wonder, if you are thinking about the level arm, will be 0.824 meter, and finally I will find the zero momentum. And the fuel usage, which is the 38 kilogram, because of the maximum takeoff weight, which is the 730, I can just put the 38 kilogram of the fuel. And please don't consider we are writing over that kilogram, but when we are refueling the aircraft, we use the liters. And our density of the fuel, which is the 0.75 liter kilogram divided liter, That's the reason we are putting the airplane in the 50 liter, almost more than a little bit more than the 50 liters, but we will write over that the 38 kilogram due to density. And the level arm is exactly the same of our baggage area, which is the 0.824 meter. And finally, I will find the momentum of this fuel, 31.996 kilogram meter. And end of the day, end of this calculation, I have to I have to sum all these weights, which is the 730 kilogram, also maximum takeoff and the maximum landing weight of the Diamond DV20. And also I have the momentum, the total momentum of this calculation, 204.996 kilogram meter. If we divide these values, I will find the center of gravity position. If I divide the 204.996 divided 730, I will find 0.285 meter, and it equals to 285 millimeter. And I will cross check from my graph. I just finished my table, I made our calculation, and I find the total momentum, total weight, and then I divided the total momentum to total weight, and I find my center of gravity position. Over there, I am coming to my graph. As you see over there, my kilogram is 730, and I go there. This is the top line, and because of our maximum takeoff weight, and I go through my total momentum, which is the 204, and it's going like up this way, and then we are in the limitation of the normal category, and our center of gravity almost to 285, as you see over there. And according to my calculation, we are in the normal range and we are good to go. At that point, I would like to also mention, if we are in normal range, our airplane can handle the 4.4 positive G rate and then 2.2 negative G rate. But due to our Rotax engine limitation, we are not able to do our 4.4 G maneuver or the minus 2.2 G maneuver, and this will be another video topic. But I would like to mention for another airplane has also the utility category. If we reduce our weight of the airplane, such as the pilot or the fuel weight, and we will be in the utility category. And if you are in the utility category, you will be approved to make the spin entry or the spin recovery from that. And that's all for the center of gravity and the weight and balance calculation. And you have to be in the limitation, not out of the graph or not out of the calculation. And thanks to that, you will be not so front heavy or so nose heavy. You will fly in the best configuration if you do the calculation before the flight.